Good afternoon, participants. We will start the session shortly.
Hello, ma'am. Ma'am,
Yes, sir. Can you hear me? Sir?
sorry, start, ma'am. Stop.
Yes, sir. Yes, sir. We can start.
Yeah, okay.
Very good afternoon to everyone gathered here with great joy and immense exultation. Sunshine is a welcome thing. It brings a lot of brightness. I feel privileged to extend my warm welcome to today's session by resource person Dr. R.M. Swarnapriya, Associate Professor, School of Information Technology and Engineering, VIT University, Vellore. And wish to welcome all the participants for the Day 2 Session 2 of AICT ATAL sponsored Faculty Development Program on Internet of Things. The presence of a true spiritual teacher, reading inspiring words and letting in inspiring thoughts tend to make the mind peaceful. Before going to a session, let me see the short intro about our resource person, Dr. R.M. Swarnapriya ma'am. She obtained her Bachelor of Engineering in Computer Science and Engineering from Sona College of Technology, and she completed her Master of Engineering in Computer Software Engineering from Anna University, Chennai. And she obtained her doctoral degree in Hyperspectral Satellite Imagery from Vellore Institute of Technology. Her main research areas are Internet of Things, embedded system, digital logic, artificial intelligence, machine learning, and advanced image processing. She has the skills in various domains like digital logic, microprocessor, embedded system, big data analysis, deep learning, FPGA, satellite image processing, Arduino, Raspberry Pi, and so on. She possesses best experiences in teaching as well as in the research. Presently, she is working as an associate professor, School of Information Technology and Engineering, VIT University, Vellore. She presented a paper in several international conferences and published more than 12 papers in various international journals. She acted as a chairperson and delivered a special lectures in many international and national conferences and workshops. She also did the several projects during her study as well as her career, like hosting for the interest of great works, analysis of a multi-temporal hyperspectral satellite imagery, and etc. She is a successful person. There is a no limit of words for her success. Now I request our resource person, Dr. R.M. Swarnapriya, to deliver her speech on the topic of IoT for a smart life. Please, ma'am. Ma'am, you can share your slide, ma'am.
Yeah, thank you. I think I got disconnected in between due to some network problem. Zoom got disconnected. Okay, so good afternoon, all. So, are the participants muted by the admin, or is it like they can unmute themselves?
They can unmute themselves, ma'am.
Okay, fine. Okay, then. So, good afternoon, all participants. So, thank you, Mr. Bhaskar, for the wonderful introduction. So, my major domain in which right now, past some 3 to 4 years, I'm working is on IoT, and we call it IoE. In simple terms, we call it Internet of Everything. So, we have a team of people. We are working here with students as well as with certain research scholars, and we are also doing projects on implementing these IoT and IoE stuffs in real time with the different domains. Like we are working with even mechanical people, mechanical domain. We are working with agricultural domain, civil. So almost in all domains, we are trying to implement all these smartness. So in today's session, so I think I'm given with two sessions today. So the forthcoming session also I'll be handling. So it will be completely hands-on, right? So let me share the screen first. So please let me know if you are able to view the screen.
Yes, ma'am. Screen is visible, ma'am.
Okay, fine. And there is a request on from my side to the participants. So today's complete session. So I will not be going much into these kinds of presentations and stuff. So I'll be just moving on into introduction, which will be some 15 minutes maximum, 15 to 20 minutes. Then I'll be moving directly into how you can implement the physical things. So going into the entire IoT implementation, that is analytics, passing over to the internet, then performing all these deep learning or machine learning algorithms over it, and predictive analysis, all these we can do. But the that we require in completely continuous 5 days or 6 days for that level of expertise and hands-on. So I'll be dealing with the physical things. That is, I'll be giving you some practical exposure, how you can make your things to talk. Fine. So I would say, make my things to talk. What is that? So I can say, see, we know that human beings, we have the capacity to talk. Now, if suppose I have a pen or a pencil, and I want that pen and pencil to talk, how is it possible? So that is going to be some fantasy. We have heard of all these in fairy tales, right? Maybe in our kids, when we were in school ages, or our grandma or grandpa would have told us certain fairy tales where we would have heard like a toy is talking, frog is talking, all these stuffs, right? So now this can be, we can say that a dream coming true or something. You can make everything in the world to talk. Or I can say in other terms, that can let you know what it is actually doing. So that is the physical layer. We call it the physical things, right? So that we'll be seeing today. So in between, if you feel like you are not able to follow on whatever I'm doing on the practical part, you can just stop me in between. You can ask me to repeat. Fine. And I think you would have got the list of requirements already. So have you people got the requirements? I had given two requirements for these two sessions. Hope you would have got. Can anyone respond to me whether you have got, or do I I have to repeat that? Guys, am I audible?
Yes, ma'am. Ma'am, once again repeat, ma'am. You participants are there. Yes.
No, the prerequisites, like I think I have shared two requirements for this hands-on session. So is that informed to the participants?
Dear participants, the tools required is posted in chat box. Kindly note it.
Okay, Fine. So anyway, I will also proceed with that. So before we move on to the practical part, so let me first move on to the introduction of it. So as I said, I'll be discussing about the IoT for smart life. See, the smart life is a fancy term. Anything we make that to be smart. So everything can be smart in this world. That is what we say for a smart life, right? So IoT for a smart life. I'll be moving on into hands-on part totally. So as I was already introduced by Mr. Bhaskar, I am Dr. Swanapriya RM from the IT Vellore. So I'm working on this IoT and embedded systems and microcontrollers and stuff. We are working on real-time projects as well, right? So let me move on to the session. So before we start on to this, I said smart life. Fine. So let us see what is that revolution in communication. So maybe you would have come across, being today the second day, you would have got some basic idea about what is IoT, right? And so many people would have talked about industrial revolution and maybe industry 4.0, something and all they would have talked. So I'm going to just say you simple introduction, just 10 to 15 minutes on this. So I would say revolution in communication. So what is that? Communication is like, see how all these technologies are brought into the world. That is just because of this communication. So initial, first and foremost, technology or the invention or discovery, whatever we can say for better communication was this printing press. So what is this? So this is a printing press. I would say that always this printing press is going to be a very best innovation, which was the first one which helped in communication. Why this printing press? So initially, you even now you can think about. So there were so many people who were writing, right? So many poets and so many people they were writing. Though they were sitting and writing, so whatever they have written, that could not be given as a copy to others, right? So they couldn't communicate whatever they did. So for that, for since they, and moreover, on a single day, maybe one person can write some 10 to 15 pages or maximum of 100 pages, not more than that. And again, if they have to give a copy to his friend or something, so someone, then in that case, what they have to do, they have to again write a copy. So that was really a tedious job. So they wanted to communicate among themselves and they went for this printing press. That is, when you make one copy, when you write a copy, they wanted to go for printing it into books and something, and they started communicating, right? So that is the first revolution, I would say, first level of revolution in communication. Then this we know what it is. So it is a telephone. So instead of writing and instead of talking and sending letters and all those stuff, so Mr. Graham Bell, so we know he invented this telephone. So which is the next level of communication. So you can ring up to anyone and you can just call and you can say whatever you wanted, you can talk, you communicate with them, right? Again, there was a trouble. So what was the trouble? So maybe even the recent generation will not know. So we used to say STD, ISD. So what is that STD? STD is something, if suppose I want to talk out of my state, then I would call it as STD. I'm in Tamil Nadu, I want to talk to someone in Kerala. So it is considered to be STD. If I want to talk to someone out of India, I would call it as ISD, right? And you need to book and you have to wait for it. And even in the previous years, in the beginning stages, they were calling it as trunk call, right? So you need to book, you have to wait, and you have to book for how many minutes you want to talk, all these stuff. That was again troublesome. So what they did, they wanted to communicate easily. So now we have this recent revolution, which is World Wide Web. So which is again invented only for the sake of communication, right? Fine. So now this World Wide Web is the communication technology where we are right now. So already people are interconnected. So World Wide Web, what it did? So it has interconnected the people all over the world. Fine. So this is the level of revolution in communication. So now what is happening? So we already know Internet appears everywhere in the world. It is primarily connection between people, right? You are going to connect people. So that is internet. So what is this internet of things, right? So with internet, we are going to connect things. So I say internet of things. So what is that? It is a plan to connect things along with some medium, right? Not only people, you can connect the people with the things, you can connect people with people is internet, people with things, and things with things, everything is internet of things, right? So that is the idea right now. So you have the internet, and in the internet of things, along with the internet is considered to be a same medium using which you connected the people. Now we are going to try to connect all the things, right? All physical things. So it is internet of things. So what is the idea? You're going to move from internet of people to internet of things. Fine. Yes. So what is this? People connecting with things. So you would have come across all these. So this is a simple example here. So I have a person, he has a motion sensor, right? So it is a sensor which is tied as a belt or something over his foot. So you have the motion sensor over his hand, right? And you have one sensor which is the CG sensor, which can calculate the pulse rate, right? So if he is running or walking, you want to get to know what is his pulse rate, whether he is healthy or not, right? So what these sensors will do, so this is the thing. Fine. Yes. So this is going to be the thing. So this thing you are going to connect using internet. Okay. So that data is going to be passed over to internet, and from internet it is going to be passed over to the hospital or wherever you want. Right. Fine. So you're going to connect people with things using the medium internet. So that is internet of things. And things connecting with things is also possible. See, you can connect your car with anything, right? So you can have heterogeneous networks. You can connect a car with a car, and you can connect a car with a house, whatever you want. Fine. So everywhere you have the internet to be your medium. That is your internet of things, right? So nowadays this internet of things, instead of saying IoT, they call it as IoE. That is internet of everything. So whatever you want to connect, you can connect. So that is internet of everything. Fine. So that is the level right now. Okay. So what are we going to do in this forthcoming 2 hours or 2.5 hours, whatever it is, right? So 2 hours, if I say, so now consider that you have a chair, all right? Yes. Now I have a chair somewhere in my, maybe consider that this is a chair which is available in a common place, maybe in a laboratory in your college, right? And you want to get to know whether the chair is occupied by someone. Yes, pardon? Someone had a question? Okay, let me continue. So now consider that I have a chair which is available in a laboratory, and I want to know whether the chair is occupied or not. Fine. So how do I do it? So you can't do this with a simple chair. So you require a chair which will say that, see, someone is sitting over me. And so it should also say that no one is sitting, I'm free. So this is what I told, that you are going to make the thing to talk, right? Yes, fine. So now what I can do here, I can either keep up, you can place a pressure sensor. Okay, so you can place a pressure sensor over it, and you can find out. So if I place a pressure sensor somewhere here, and if someone is sitting, the pressure is going to be becoming a bit higher, right? And you can place a threshold value, and you can say now the someone is sitting there. So you can say the chair is occupied. Fine. Or there are varieties of ways like that. So you can place a heat sensor. So what is this heat sensor going to do? It is going to calculate how much of heat is being generated. Suppose a human being is sitting over it, he will have a body temperature which is going to be passed over, right? So obviously some heat is going to be absorbed by that heat sensor, and you can identify, yes, a person is sitting there. Fine. Suppose apart from that, you require to know who is sitting. Then in that case, you can either place a camera, you can find out using face recognition, seeing who is sitting there. Or you can use an RFID reader and you can place there and you can say who is going to sit there. Fine. So all these we can do. How we can do? So you are going to convert this thing. So thing is a chair. This thing you need to convert so that it is going to help you to act smart. It has to act smart. Or I can say I have to give some intelligence to it. So how we are going to do? So that is where our Arduino comes. Or we can say that this is a microcontroller. Fine. So it is not a simple microcontroller. So this is a development board. So we call this a development board where you have the microcontroller built inside. Fine. So usually when you start the initial stage of your implementation for or any kind of Internet of Things or anything, so what you can do is always Arduino is the base with which you can start and program. Then now you have got all these data from the sensor. So you have got what is the heat? Yes, the heat on the chair is going to be some 1 or 2 degrees Celsius. So you have got it. So how you are going to send it? So you require some internet or I say some Wi-Fi. So a combination of all these three will make the Internet of Things, right? So internet is going to be the medium via which you are going to pass the raw data which is being collected using all these development boards and the sensors which is placed on the things so that the things will act too smart. Fine. So this is what we will be seeing in this session, but I'll not be able to cover this part. Fine. So my major focus will be on these things, right? How you can make the physical things, and I'll be moving on into programming, right? Basic programming on how to use each and every basic sensors. Using that basic knowledge, you can then move on into few your own projects, some prototypes, and then you can proceed, right? Fine. So let me move on into what? Fine. So as I told, that is your Arduino development board. So you require one Arduino development board if you are really interested in working on with hardware. But today, since you people will not be having hardware and since it is not a physical workshop, we are going to do the same thing with another tool which will help you to see the same output whatever you are going to see on naked eye on your board. I will also be giving you, see that whatever we are going to do with the simulator, that is going to be the same what you are going to do on the Arduino board. So if this code and if this circuit works here, the same thing when you do it on the hardware, the same thing will work. Fine. I'll let you know how it is. Fine. So we will move on to what? So in this Arduino development board, you have a microcontroller, which we call it as this ATMEL Atmega, right? So there are other microcontrollers with which you can work. So for example, embedded systems, we usually work with 8051, right? So the microcontroller. So we have so many microcontrollers with which you can work. So the basic one for any beginner to start with any basic project, it is Arduino development board. That is what we use, right? The other one is usually which is used in real time. You say it is Raspberry Pi. We use in real time. Fine. Yes. So now let's see here. Now in Arduino development board, we have a built-in microcontroller, which is going to help you to control all these stuff. And you have certain digital IO pins. See, I have specified here where the digital IO pins are in your microcontroller. Fine. So all these, this side, so these pins are digital IO pins. You have 13 pins here, right? So 13 digital IO pins, digital input output. And you have here the other side, which is analog IO pins. Then you have power pins, which is the 5 volts and grounds 3.3 volts are also there, right? So generally we prefer this 5 volts. So we say 5 volts or we say VCC. So any electronics or electrical people here, so you know what is that VCC. So this can accept 5 volts, and in some cases we need to provide only 3.3 volts. So you can even go with 3.3 power pin also, right? And this is what is required for you for programming right now. And you have a part where in Arduino you will have one USB jack. So this is the place where you can connect your USB with your computer or with your laptop. So for what it is required, after you write the code, so now we'll be writing the code and trying to run it in a simulator. So after you write the code, if you have the hardware Arduino on hand, you will connect this USB jack with your laptop, and that code you can write inside your microcontroller, that is inside your Arduino board, and you can make it work. Fine? Yes. So this is what we need to know about Arduino development mode. I'm not moving into the exact architecture of it, so which is not to the scope of this particular session. So we'll be just getting into the programming part right now. So before we move on into the programming part, so there are few terminologies which are available for this Arduino programming. So the first one, we call it as a sketch. So in Arduino, any program you write, we call it as a sketch, right? So you write a program, and if you want to run it on the board or if you want to run it on the simulator, we call that as a sketch. And you have a pin, we call the term to be pin. So pin is something which is going to be either the input or the output. So for example, now I say the temperature sensor, right? So the temperature sensor will be considered as input because I want to calculate the heat, and based on that heat, I'm going to take some decision. So obviously, temperature sensor input is considered to be the input, and you're going to take some decision that is going to be considered as output, right? So this is the difference. So every pin you're going to use. So I have already told you have some 13 digital pins. You have certain analog pins. So these pins you have to first configure to know whether it is going to act as an input or the output, right? So this is the other terminology which we'll be using, which is widely used, right? Then you have the digital. So if you're going to go with a digital pin input or output, the value is either going to be high or low. High means it is on state, low means it is off state. So in other terms, I can say high means 5 volts, right? So it is 5 volts. Low means it is 0 volts. So if you say I'm going to connect it to 5 volts, it is high. When it is 0 volts, it is low. Or in simple terms, on means high, off means low, right? So just switch state, and you have the analog. So the value ranges from this 0 to 255. You can have some values there. So you can give the motor speed or LED brightness, the brightness level, all those stuffs. If you're going to vary, we call it as analog. So we'll see few examples of which sensor works as analog, which is going to work as digital, everything. So few basic examples and projects I'll be explaining to you today, right? Fine. So the next, so we'll move on to this programming, right? So when I say this programming, so you can move on into Arduino.cc, and you can download the recent IDE there, Arduino IDE. If you have already downloaded, it is fine. If you have not, please you can download and you can install. It is a very small file. You can just download and you can install it. Fine. Yes. So after you install, you will get this particular window. So I will show you the exact environment. So just for basic terminologies, I am using this presentation. Then I'll start sharing my desktop and I will explain you the exact environment. So when I move on to the Arduino IDE, you will get this particular window, right? So you can see, so it is given here sketch, right? So it is a new program. Fine. Yes. So here in this, you have to have three things in mind. So the code you write in Arduino is going to be case sensitive. Code is completely case sensitive. Then the statements are commands. always should end with a semicolon. Each and every command should end with a semicolon. That also you have to have in mind. Then, if you are going to have any comment there, either if it is a single line comment, you can use two slashes, right? If you have multiple line comments, you can start it with this and you can end with one asterisk and a slash, right? So these are the three basic stuffs. So which you have to have in mind. So it is code sensitive, case sensitive. Code is code case sensitive. So you know what is case sensitive, because in some commands you will have uppercase in between. In some commands, everything will be lowercase, right? So you need to have that in mind. Fine. So what is the minimum code or bare minimum code I would call? When you open the Arduino IDE, you will get these two bare minimum code which is available. So the first one, this is one function which is void setup. So what is this void? So void is going to say that there is no return value. And this setup is a built-in function, right? So we are not, you don't have the rights to change these. So you can't name it as you wish. If you want to create your own user-defined function, yes, it is possible. But at this stage, it is not required being a beginner. So we'll start only with this setup and loop, right? So this is the minimum code you require for any Arduino programming, right? Yes. So, and this setup. So when you say setup, always you are going to set up everything here. So as the name suggests, setup. So you are going to declare the variables here. You are going to declare your pin here. So which pin is going to be used in which mode. So you're going to use a different setting up. All the setting up of the environment will be done here, right? So always the Arduino, when it starts running, the first one which it will go and search and which it will execute and compile is the setup function. So you're going to give all the basic requirements. All declarations will be inside your setup. And loop is something where you're going to get the value of the sensor, get the raw data, and then you're going to take some decisions based on it. All conditions you are going to do, and which has to be repeatedly running. This is similar to your while loop in usual programming. So this is the loop function, right? So when we move on into few examples, you will have a better idea. So just get to know the basics alone, right? Fine. So this is the minimum code you require. One is the setup function, the other one is the loop function. In setup, you are going to give all the basic environmental setups. Then in loop, you are going to give the code which is going to help you for running repeatedly. Okay. So as I already told, every pin you have to set whether the pin is going to act as input pin or output pin. Fine. So for that, you have one basic function built-in method, which is pin mode. Yes, a pin on Arduino always is either set as input or output using this pin mode function. So what is the syntax here? So here pin mode, you can see here M is uppercase, right? So pin mode, M is uppercase and all the others are lowercase. So you have to have this in mind. If you give M to be lowercase, you will get error. Fine. And this first argument, so you have two arguments here. The first argument is specifying the pin number, right? So this is going to specify the pin number. So you need to have the numbering here. So I say pin number. So where do you get the pin number? So I have already shown you the Arduino development board, right? So let me show that. So I have specified here 13. So you can see this is the Arduino board. So where you have 13. So this is a digital pin, right? So these pin numbers you can use there. And if you are going to use analog input, you will use the pin number to be A0 to A5. So whatever is there on the board, directly you can use there on the coding. Fine. So that is what I have specified there. So pin mode 13. So I have said 13 comma output. So see, all are in uppercase. You should not give them as lowercase. All are going to be in uppercase. So I say pin mode 13 comma output. So what I'm doing, I'm setting the pin number 13, that is the digital pin 13 as output pin. Okay, fine. And if suppose you want to make it to be input, so how you can make it is again pin mode 13 comma input. So you can make the pin 13 to be input. So if it is input, if it is going to act as input, you are going to give it as input. If it is going to act as output, you are going to give it as output, right? So this is one major function which is used. Always the spin mode will be given in the setup function. This you have to have in mind. So because we are going to set up the environment, so all these pin mode functions generally comes only in the setup function in your minimum code. Then how you can read and write the digital values. So for reading and writing the digital values, see you have a method which is digital write. Fine, you can see W is uppercase, so digital write. So now if I say 13, so already I had made 13 as output, right? So initially what I did, I made, if suppose the pin number 13 is made as output, then you can write over it. If you have made it as input, you have to read, right? Input means you're going to get it as input. Output is you're going to give it to the outside world. So if you're going to give it to someone, you're going to use digital write. If you're going to get it from the sensor, you're going to make it as digital read. Okay. So now when I say low, so what is this low? It means it is 0 volt. Already we have seen for digital high and low. High means 5 volts, low means 0. Okay, so I say digital write 13 comma low. So this is only for writing and reading digital values, not analog. Okay, then digital write 13 comma high. Fine, you can make, if you want to make it high, that is 5 volts, you can use 5 volts here. Okay, fine. So this is how you can write certain digital values. And if you want to read and write analog values, as I said, analog values, you have the pin number A0 to A5. Okay, and you have a function which we call it as analog read. Okay, analog read means here R is uppercase. So what I'm going to do, I have to read some value which is connected with A0. Whichever sensor is connected with A0, from there I'm going to read the values. So that is analog read. Okay, and analog write, what you would do, the pin number you can directly say, and you can give the value which you are going to write. Okay, analog write you can do. Fine. Yes. So then you have a timing function which is always used. So we have the timing here. Always by default, the timing is in milliseconds. Now I can use a function, we call it as delay here, delay within milliseconds. So you can give the milliseconds with the number. So I can say 1000 or something, right? So which means 1000 milliseconds. Delay is something like a sleep function. It is similar to a sleep function, which I'm going to say you're going to give some gap. So let us see why we require this delay when we implement some examples. Okay, if you want that to be in microseconds, you have a function which is called as delay microseconds, and you can give the microseconds within the braces. So this is with your Arduino timing. So this is the other function which is generally used. Okay, so we have seen few functions. One is the setup, the other one is loop. So within setup, we have to set up all the environments. Then within setup, generally you set the mode of the pin. So for that you have a function which is called as pin mode, right? And you can set it as either input or output. Then within the loop function, you can give all the looping manners, or you can say whichever is you want to run repeatedly. Then we have seen how you can write a digital pin, how you can read from a digital pin, how you can write an analog pin, how you can read an analog pin, and also one function which is for timing. One is delay, the other one is delay microseconds. So these are frequently used. So with whatever we have seen now, let us try implementing it with some basic programming. Fine. So let me start sharing my desktop. Okay. So before we start with that, yes. And do anyone have any doubts here? If anyone is having any doubt, so I can clarify. Okay, so let me share my desktop. Fine. So I think you are able to see a browser right now.
Yes, ma'am. Visible, ma'am.
Yeah, fine. So if you had not downloaded the Arduino, fine. So you can go with arduino.cc, right? So click go with this arduino.cc in home, and you can go for downloading the software, which is the IDE. If you directly go here, you can download the software. See here, and you can go with downloads directly, and you will have this Arduino IDE 1.8.13. Fine. So here you have so many versions. So you have Linux version, you have Mac version, you have Windows version. So you can get all these. So you can just download this. Fine. Download it and you can install. So this is what is required. The software, the Arduino IDE is required for us to program. Apart from that, I had given the other one, which is this Tinkercad. Okay, so I already have an account here. So if you are the first time user, so you can directly go into this tinkercad.com, or you can go into this Google and you can type Tinkercad. Fine. So you will get here tinkercad.com. Fine. So you can directly go into this, and then you can create your account. So you just, it will just ask you to create a account using email ID, or you can even use your Google login for that. So if you create, you can directly get into this dashboard. Okay, so it will automatically move into the dashboard. So this Tinkercad is the place where we are going to create our circuits. We are going to check whether it is going to work with Arduino, and we can feel the exact output what we would get on the hardware. Since most of you will not have access to hardware right now, I am using this Tinkercad. If you have the hardware, it is well and good. Otherwise, usually what we do is we check out whether the code works on the simulator. If it is going to work, we will then implement it, directly post it inside the hardware, and you can work on. Fine. So you can start before you get the feel of this physical things. You can use this, but you can't move on using it forever, because this doesn't have very high end implementation and all. So basic implementations it is having, so you can do those basic implementations with the tools available here. If you want to go with that Wi-Fi, that is I show, right, a medium where you can collect the data and analyze and go for algorithms and come with predictive analysis, all those we have to do only with hardware. You don't have a simulator which can help it. Okay, fine. So now let's move on. I will give you the general steps for that. Fine. So before that, let me move on with the Arduino IDE. So let me share the Arduino IDE. So if you have downloaded the Arduino IDE, you can continue along with me. Maybe you can download side by side. So let me start the Arduino IDE and I will move on. Okay. Fine. Fine. So this are you able to view one IDE right now?
Yes, ma'am. Visible, ma'am.
Yes. So this is the Arduino IDE. So I have my own version in my laptop. So if you have downloaded, you can install it. And when you open, you will get some basic programming already, demo programming available. So I'll let you know what is that. So before that, so this is what I showed you. So is this screen clear to you? Are you able to visualize it?
Yes, ma'am, it's clear, ma'am.
Yes, fine. So you can see here, there is something called a sketch. So if you want to create a new program, you directly go into this file, new you can give, you will open, you will get one sketch opened. So in this sketch, as I already told you, see, you can see here, there are two basic programming stuff, which is void setup is available already, and you have this void loop. See, I am
Ma'am,
removing the
sorry for
comments
this
here.
disturbance, ma'am. Ma'am, your new file screen is not visible, ma'am.
Pardon, pa?
Your new file screen is not visible, ma'am. That bus.imo file is only visible, ma'am.
Okay, fine. Is it visible right now?
Yes, ma'am.
Okay, so now we have this void setup and void loop file. So let me increase the font size. Maybe it will be better visible to you, so that when I code, it will be easier. Okay, fine. So now we have these two functions. One is the void setup, the other one is void loop, right? So in setup, we require to set up the entire variable. Now let us just start with basic implementation. Now I say I'm going to make one LED to glow, right? Maybe I can consider to be it is in on and off state, something like that, or we simply say that it has to blink. Okay, so I want my LED to blink. So with whatever we have already seen, so we have seen few functions which we can use, the basic functions. So with that, let us try coding this, right? So first, what we have to do, we have to first set whether the pin is going to act as input or output. So when I say LED, so what is this LED? It is a bulb kind of stuff. So instead of a bulb, I can use one LED which can be either made to glow or you can off it, right? If I say I want to blink, I want to make the LED to blink, what I have to do? Maybe in one for 1 second it has to glow. Then for next 1 second it has to be in off state. Then another next 1 second it has to glow. So then it is going to be blinking, right? So we will move step by step. Now first, what I have to do, I have to set up the environment. So in my setup, I'm going to use pin mode, right? So we have already seen in digital, you have some 13 digital pins. So now, how do I identify whether my implementation is going to consist of digital or analog? So you can see this LED. So LED has only two states. One is off, the other one is on. So when it is either off and on, or I say 0, 1, so it is going to be digital, right? Simple. Suppose if I say temperature, so what is going to happen? Temperature can vary from 0 to 100 degrees Celsius or something, right? So it can have varieties of values. It is not going to be restricted to only two values. When it is not going to be restricted to only two values, we consider that to be the implementation should be analog. This is how you can differentiate, right? So now I say LED is a digital. So we know digital pins, you have 13 pins. See, you can use any pin you want. From 0 to 13, you can use anything. Fine. From 1 to 13. I am always, the default compatible one is 13 I use. So whichever you are happy, you are comfortable, you can use. Fine. So now I say pin mode 13 comma something. So what is that something? You have to make it either as input or output. See, I am not going to give it as input because as an user, I am not going to give any input to that LED. So what I'm going to make, I have to view it. I have to view whether it is on or off. So it is going to act as output pin. So I say output and I give a semicolon here. Okay. So this is what I'm going to set up. So now I've set up just a simple LED and I'm saying pin mode 13 comma output. Okay, so now I have set up the environment. So now what I have to do, I have to make the LED to be on for some time or off for some time. So first let me make it on. So for making it on, what I have to going to do, I am going to write something over the digital, right? So what for writing something on the digital pin, what function you have? You have digital write. Okay. So digital write, the 13th pin, what I am going to do, I am going to make high. Make high means what? I am going to make it glow. Okay, fine. Yes. And then what I have to do? I have to again make it off. I have to off that for a few seconds. Okay. So again I say digital write 13 comma low. Now will this work? It should work. Actually, theoretically, this should work, but it will not work. I will say why. See now, when I have made first digital write 13 comma high, yes, now the LED is on, but I have not given any differentiation or any time in between which will help me to view the difference. So what I told when I gave the requirement, I told for 1 second it has to be in on state. For 1 second it has to be in off state, right? So that 1 second, that timing you have to give. So what is the function you have for timing? You have a function called as delay, right? So we already saw that. So I say delay and I say 1 second. So 1 second is 1000 milliseconds is what is 1 second. Fine. So I say here 1000. Again, here I am giving delay of 1000, right? Yes. Now if you see after glowing high, it will wait till 1 second and then again I make it low and it will be again low for 1 second. Again this will be continuing because it is a loop. Again and again it will continue until the Arduino is given power. Fine. Yes. So this is how, this is a very simple program. This is a very simple basic logic. This is how you can understand any physical thing. So whatever you want to do with the thing, that you have to understand and visualize and you can program. See, programming with the Arduino is very easy. Fine. So just simple terms, but for each and every sensor and each and every input, you have a different methodology. Usually, almost everything will have the same methodology. Some cases you have different functions which can be used. I will let you know the difference. Fine. The way of connection alone is going to vary, but the way of writing code is going to be almost the same. Fine. So after you write the code, now you just get to know, now you want to know whether there is some syntax errors or whether the code will run or not. So how do you do that? See, you have, this is verify. So there is a tick mark here, which we call it as verify, which is going to compile. Without compiling, you cannot check whether you have errors. So now let me see, I am going to verify. So when I say I am going to verify, it will ask me to save it. Okay. So either you can save or you can directly give cancel. It will also get automatically compiled. Whichever is comfortable, you can do. And if you are going to save, you are going to save it with extension .ino. Okay. Now see, you get one thing which is a status compiling the sketch. So it is giving you a status bar, a green bar. After it compiles completely, it will say compiled or it will say done compiling. Suppose there are few errors, it will give you throw some errors. Okay, fine. So this is how you can write the code. So this is the basic level of writing the code. Okay, so let it check. Yes, see, it is saying done compiling. Fine. So it means there are no errors. So this is how you can write the code and you can check whether there are few errors. So if suppose you are going to connect it to, now I want to write this code into Arduino board. If you have a hardware, that is your Arduino development board, if you have on hand, you can connect the Arduino board using USB connector with your laptop, and in tools you can directly go here, fine, and in board, I see in my case, I have this board selected as Arduino In some cases, when you directly first time when you install, you will have the board something else. Some cases it will be Arduino Fio, some cases it will be Arduino Mini. But generally, what we use Arduino Uno. Fine. So you need to select from this the boards. So you can select that. After you select that, you can directly go and program. You can go for adding it to your code. You can transfer the code inside your Arduino. Fine. Yes. So now we are not going into it. So what we are going to do now, we are going to check out with how you can do this with Tinkercad. So this code I am going to give connection using the Tinkercad, and the same connectivity you can use even with your hardware. Nothing is going to be different. Fine. Same connectivity you will use with hardware. So let me move on to the Tinkercad now. So Tinkercad. So I have already shown you that Tinkercad. Fine. So now are you able to view my dashboard of Tinkercad?
Yes, ma'am.
Yeah, fine. So now before we start, so let me create. So you can see here the dashboard you have. Here you have so many stuffs. So these are few projects which I did in the previous FDP. So after you create all these, you will have all these whichever circuits and stuffs you have created. So let me create a new project today. So this is the project 2. Fine. So let me rename this. So I am renaming the project. So you can create a project right now so that all the circuits whichever you create will be inside that. Fine. Um, Okay, so let me create. Now I've created the project. So here, after you create this project, see you have a create button. So you can click over create. See you have so many 3D design, code blocks, everything. Now we are going to create a circuit, right? I'm going to give connection with the Arduino board. All the circuits I'm going to do. So I say create a new circuit. Okay, when I create a new circuit, see you will get here the dashboard loaded with all these requirements. Fine. So you can see here towards the right, see you have so many stuffs. Okay, so you have ultrasonic sensor, you have a buzzer, everything. Fine. So here in components, you can select all. By default, it will be basic. Please select all here. Then you can directly proceed. Okay, so you can see here all the components which are available here for circuit design will be there. Okay, yes. Okay, so now let's go and place the Arduino, right? So now I say Arduino. When I search Arduino, see here you have the microcontroller. I say Arduino Uno R3, right? So you can drag and drop here. So this is the hardware which you will have in hand also when you purchase. I'll also show you which you can purchase if you are interested, right? So now this is the Arduino development board. You can drag and drop. See, as I told, see you have here some digital pins. See, 13 digital pins are there, and you have analog pins here, A0 to A5, right? So analog pins are there here, right? So now I have this Arduino board. So now what I have to do, as I already told, I'm going to have one LED. See, when I type LED, see here you get so many tools, right? You can select this LED, drag and drop here. Okay, so you can have your own color. So you have a red, you have green, you have yellow, orange, anything. So this is going to be the manner in which it is going to glow. That's it, right? So the color of LED, or you can say the color of the light, whatever it is, blue or orange or whatever it is. So let me go with orange. Fine. So now I have placed this LED. So what I'm going to do, I have to now give the connections. Okay, so just one LED and one Arduino I have placed. Okay, so now what I'm going to do, see here. So this is anode, the other one is cathode, right? So in one LED, when you get one LED in your General LED, if you get a hardware LED, right? A simple small bulb like thing you will get. So here you will have one long leg. So in LED, you have one long leg. You can see here in the picture also, see this is a little bent. Similar to this, you will have. So this bent one is your anode, the other one is your cathode. So the anode is your positive and cathode is negative. So in terms, I say cathode is negative, anode is positive. So always the positive side is going to be connected to the digital pin. So in our coding, which digital pin we used? We used number 13. So when you just place your cursor there and you just drag it, you will get a wire kind of stuff. You can drag and connect it to 13. And usually the procedure for any circuit designers, when you are going to connect the positive part, you make it to be red. Okay, and the other negative one is always going to be grounded. See, you have one ground here, GND specifies ground, and that the color of the wire will be black. Fine. So this is the basic usual terminology which we use. So we are going to use the same terminology. So this is generally for the better understanding, and the circuit also will look better, right? So it will be good to see different colors. And if you use the same terminology everywhere, it will also be easier for you to debug if you have few errors. For simple circuits, it is not a problem. But if you have few complex circuits, then for debugging, you require this coloring codes. Okay. So always the positive, that is the pin wherever you connect, the positive edge is considered to be in red color. The other one is in black, which is your ground. Okay. So this is how you can connect. Always the negative is going to be grounded. The positive is going to be given to the pin. Already we set the digital pin 13 to be the output pin. So I've used that same 13 here. Okay, so that's it. So this is what is the connection we are going to give. Okay, so now how we are going to code. So before that, see, you have here some different names, monkey something. See, I don't want this. So what I can do, you just place your cursor and tap. Just click once. You can rename it. Maybe I can say blinking LED is my program. So, okay, so I say blinking LED, fine, and I can press enter. So it will automatically get changed the title, fine. So the circuit name you are going to change here. Now let's see how we have to code. So now you have this code here. Okay, so whichever code we did in Arduino, the same thing you have to give here so that it will work. You can go for checking out whether it is going to work. So now you have here in the top right corner, you have C code, you have start simulation, you have export, you have share. So now when I click on code, see, you have blocks, fine. So we will not be going into blocks. So we will use the text code. So when you click on, it will say, are you sure you want to change the blocks? Yes. Fine. So now this is the code which we wrote there. Okay, I have copied and pasted here. So even you can paste it, or the very first time when you use, in some cases when you give in Tinkercad this kind of LED stuff, it will automatically generate the code. Fine. In some cases it will not generate. In some cases the code which is generated will be wrong. We need to change it. Okay. Fine. Yes. Yes, someone has raised your hand. Um, any doubts you have? Shall I proceed? Kindly repeat where you got that code. That code we wrote in the sketch. Do you remember? I explained that, right?
Ma'am, yes, ma'am. But here you click the code, right? After that, what you have clicked, ma'am?
In code,
Yes.
yes, this code. Now it is like this. Before that, you will have this one. It will be in this manner. So when you click on code, this is how the window will be. So in this blocks, you can select this text. Fine. When you click on text, you will get this part. Here you can type the code. So in this case, in some cases, if you are logged in right now, this when you connect this circuit, you will have the code already available. It would have been automatically generated. In some cases, that code will match our requirement. In some cases, it will not match. So this code we already wrote on Arduino IDE and I explained. Do you remember that? Shall I proceed?
Yes, ma'am, you can proceed, ma'am.
Yes, ma'am.
Okay, fine. And so now this is how you can write the code here. Now, after we write the code, now let's see whether it is going to work. So how do we do that? So now you have here the start or start simulation, which is just beside the code, right? So you can start the simulation. See here, it will run. See, it is glowing for some time and then it is offing for some time, then again it is glowing and offing. Are you getting this? But you get one error. So what is that? See, it is saying a warning. It is not an error, it is a warning which says current through the LED is 45.6 while recommended maximum is 20.0 milliamps. So what does that mean? It means that the current and one LED can accept only a current which is 20 milliamps. But right now the current passing over it is more than that. So that is what is that warning. So what does it mean? So it says like, see, you have given a circuit which is working fine for your code. Yes, the logic is right, the code is right, the circuit is right, everything is right. But the problem is what? The problem is now, since this is a simulation, nothing is going to happen. Now, when you use the actual hardware and when you connect the LED there, what will happen? The LED will glow for few minutes and it will fuse. Why it will fuse? So we know in bulbs in our home also, when you try to make one particular bulb glow for some time, so it will glow for years, and after that you might get some fuse there, so the fuse will go. You say fuse poet, fuse has gone, we say that. What is the meaning? It means like, so the wear and tear, in some cases it is because of wear and tear, but in our case, in the circuit, what happened? Here it is giving you one particular warning saying that, see, the current flowing over the LED is more than what it can actually accept. So what it will happen when you do the same circuit in your real time, this LED will glow for the very first time, maybe for a few seconds. After that, it will fuse. You need to change your LED again and again, new LED, new LED. So what you have to do? So in real time, when you proceed with this, we need to go with one resistor in between, which can resist the current and send the current correctly towards your LED. So what we have to do, change in the circuit. So now let's move on again. So now I'm going to click over the code and it will close automatically. Now in the components where we got all these, now I'm going to search for resistor, right? So you can click over resistor, bring the resistor here, place it over here, right? And in between this current, right? So here we directly initially connected it with the digital pin. Now what I'm going to do, I'm going to connect one resistor in between and I'm going to give the connection. And let us see whether that particular warning is moving or behind or not. So this alone I have modified, but the code I am not touching because there is no error on code, right? So you understand. So now there is no error on code. Only thing in this, it was showing a warning. That's it. So now I am trying whether I can remove that warning so that I can use the same circuit in real time. So now let's start simulating again. See now that particular warning, one exclamatory mark was coming before. Now that is not coming. Is it clear? Yes. Any doubts on this, guys? If you have any doubts, so I can wait and I can explain you. If you don't have any doubts, then I can proceed. And guys, are you guys trying the circuit and working on it side by side along with me, or do you want some time to check whether it is working? Any one of the participant, can you respond? Shall I proceed to the next implementation? Or should I wait so that you get the output? Yes, fine.
Yes,
So, okay. Well, you are working side by side? Fine. Okay. Okay. Perfect. So, if you don't get anything in between, you can stop me and ask. Okay. You can unmute yourself and you can stop me and ask. Okay. So, this is a very basic implementation which we do. So, this is how we generally check out whether this particular circuit is going to work in real time or not. Okay. Fine. Yes. So now let me move on to the next. So this is one kind. So I say LED. Okay. So there is something which I would call a buzzer. So let me stop the simulation, right? And let us move on to the next simple project. So I go back and I'm going to create a new circuit. So let me say the circuit is going to be, so like I say, create a circuit. So I let you know what circuit we will do what. So now you have heard of a buzzer, right? So an alarm or a buzzer we call. So the usual projects what we do, we say, suppose there is I'm going to implement one particular thing which is going to find out whether the light inside my room is going to be lesser than this particular intensity, then I have to switch on my tube light, something like that. Or in some cases, fire extinguishers. If there is a fire, if there is some smoke within the house, I want some alarm or buzzer to be ringing, right? So for that, you require a buzzer. So buzzer is again another kind of output which is generally used in these kinds of typical layer things, right? Yes. So now let's see how to implement those buzzer. So you have a special function for that. So let me first, as usual, let me go for placing one Arduino Uno R3 here, right? So I have placed it. Now let me go for placing a buzzer, right? So you can go for searching for a buzzer. So when you type here buzzer, see you get piezo. So this is a speaker, right? So we call it a piezo buzzer or we call it a piezo speaker. So the same way, same manner it will look in hardware also. Okay, when you purchase a buzzer, similar to this, you will have one black color speaker kind of stuff. With that, you will have two wires, one to be red, the other one to be black. So the black you will connect to the ground, red you will connect to the pin, to the output pin, whichever you want, right? So now I have placed this buzzer here. So now after you place the buzzer, so what I'm going to do, I'm going to connect it. So now this is the place, now this is positive, right? So it is saying positive. So I say I'm going to connect it to 13 and I'm going to make it red. And this is your negative. So I can ground it to this. Okay, fine. So now I have done this. So now after you connect, so always, as I said, one should be to the ground, the other should be to any pin, whichever you want. So instead of always using 13, if you feel like, no, ma'am, we will go with some other pin. Yes. So in case of piece of buzzer, the negative positive doesn't matter much always. right? So let me connect it to 9. The other one I will connect it to ground. Okay, so the ground I give it as black. The ninth pin which I am using, I am going to give it as red. Okay, fine. So now let us move on to what? So now I say the code here, right? So I click on code and in blocks, now I select text code. Okay, and give continue. See, it has come here, but the previous code, whichever we wrote, so only that code will be generated. So remember, only that LED code is going to be generated. Now nothing is going to be generated. So now what we are going to do? So we have to select we have to keep all these pin mode, everything. So you can change everything here. Now I'm going to remove all these code, whichever is available inside. So now I say void setup. So in setup, now what I have to give? I have to give the pin mode. So I say pin mode. Pin mode. So what is the pin I have used? Number 9. So I say pin mode 9, comma. So what is this pin? It is going to act as output. So I say pin mode 9, comma output. Okay. So after I say pin mode 9, comma output, now what I have to do? I have to make this buzzer to give some noise. I have to hear some noise. So what function we have? We have a function which is tone. So you can make a note of it. There is a function called as tone which you can use for making a buzzer to give some noise. Okay, so TONE, and it will take 3 arguments. The first argument is going to be the pin number to which the buzzer is connected. So now it is going to be 9. The other one, next one is going to be the sound in hertz. Okay, frequency at which the noise has to be given. Okay, usually the noise level which is which the human is able to hear it without irritation is from 2000 to 5000. Okay, more than 5000 you will feel irritated. It will be too much of noise, right? So 2000 to 5000 you can give the frequency, so which will help you to give it. The maximum value in hertz which is possible to give here is 65,535. Okay, you can have a note even, but we will not be using it much. So it is 65,535 is the maximum value you can give in the second argument. But usually I would say either go with between 2000 to 5000, not more than that. Then the third argument is for how much time it is going to give the noise. You don't want it to be always sounding. For some time you want to give. So I say 100. Okay, yes. Now I give a delay because I want this buzzer to be giving some noise or in some particular intervals alone. So I say the delay again is going to be some 1000. Okay, fine. So I've given a timing. So after some timing, that 1000 milliseconds, again it will give the beep sound. Again it will be silent for some time. Again it will give the beep sound. Okay, so now our code is over. So let us start the simulation. So are you able to hear some sound? Some beep sound?
Yes, ma'am.
Yes. So it is giving the beep sound in some interval. See, when you get the beep sound, see, it is giving that speaker sound, right? So it is giving you a difference here, right? Yes. So when you increase the delay or the time in which it is going to give the beep sound, it is going to vary. That's it. Okay. So you can try out. So this is one way of another kind of output. Okay. Fine. Yes, so you want the last code. Okay, last line of the code again. So this is the code. Yes. So now I've just given the tone there. So tone is one built-in function. So that built-in function is going to take 3 arguments. One is the first one is the pin number to which it is connected. The second one is going to be the frequency at which the sound has to come in hertz. Usually the frequency I would prefer 2000 to 5000, which is the general human pleasing here kind of stuff. Otherwise they will be irritated. The other one Last one is for the time to which that particular sound has to be given as a noise, right? So that you can give whatever number you want. Then you have a delay, which says in how much uh, delay you want the sound to be repeated again. Okay, fine. Yes. Any doubts till now? Fine. So if you don't have doubts, so just let me give you some introduction about what is that serial sharing and serial monitor kind of stuff. Okay. And then maybe I think we can wind up. Sir, the session ends at 1:30, or is it going to end at 2 o'clock?
Ma'am, it's ends at 1:30, ma'am.
1:30. Okay.
Yes.
Again, the session starts at
2:30, ma'am. 2:30 for
2:30. Fine. Okay. So before we wind up this session, let me move on to that serial part. So let me go with a new share. Let me move on to the ID again. Yes, fine. So this IDE, so we had already seen this IDE. So now this IDE, when we move on, so now I say here digital write 13 comma high, right? And I say digital write 13 comma low. So what does it mean? It means that the LED is going to be in on state for some time, in off state for some time. Suppose in computers, suppose you want something to be printed and you want to get to know, suppose your LED is not glowing. Now, as I said before, you have forgotten to give the resistor during your real-time implementation. So what will happen? Initially, when the current flows in it, the LED would have fused, but your code would have been working properly, but LED will not glow. So what you will think, hey man, my LED is not glowing. So what mistake I have done there? So is my circuit wrong? Or is the code wrong? So you will be panicking, right? So if suppose you don't want that to happen. So we have something which we call it a serial monitor. See at the top corner, you have one kind of small stuff, small circle with a line, right? So this is a serial monitor. When you place your cursor there, it will say serial monitor. So this, when you click on, okay, senior monitor, you will get, okay, you will get all those data. Now you want to print something and check out the status. Fine. Okay, so you want to print something and check out the status, so you can get that serial monitor output there. So let me say you how you can get this output return, printing some message over it. If your hardware is not working, but you want to get to know that yes, the circuit is working, or the code is working, or something like that. In that case, what you can do, so we have something, we have one particular thing, we call it as serial dot begin. Okay, so you can see here serial s is going to be uppercase, serial dot begin, and I say 9600. So let me say you what is this 9600. So I say serial dot begin 9600. So now I say I'm going to give some serial communication, or I say I'm going to print some message from my Arduino to my system monitor or to my laptop. Okay. So now when I'm going to communicate, so we say serial communication, there are varieties of devices available for that. So you have UART or USRT, whatever it is. So you have so many varieties. Now my laptop is working in a different clock, the clock cycle, and the Arduino is going to work in a different clock cycle. You want to synchronize both so that both your communication will be proper. So for that, you're going to specify the baud rate. Okay, so this we call it as baud rate. 9600 is the baud rate. Usually the standard method is using 9600. So 9600 baud rate will work fine with your Arduino and laptop. Okay. So the maximum baud rate which your Arduino supports is 1,15,200. Okay. So the Arduino supports 1,15,200. But I have not worked with this. So 9,600 works fine. You can try out with 1,15,200. That is the maximum baud rate your Arduino works. Okay. So this you have to use in the setup method. So you're going to give the synchronization baud rate. You're going to say, I'm going to send some data from my Arduino to the computer back. Okay, fine. Yes. So now what I'm going to do, I'm going to say now my LED has gone because I have not used the resistor. So what I'm going to do, I'm going to say serial dot print ln. Okay, print ln means new line. That's it. Okay, serial dot print ln, and I'm going to print something here. Yes, I have to use a double quote for printing a string. If I want some message to be printed, I have to use a double quote. Serial dot print ln, and I say LED on. Okay, because LED here I have made it high, so it is LED on. Now when LED is low, I have to say serial dot print ln, and I say here LED off. Okay, fine. So now this code will work. So this will give you one output. So let us check that in the simulator. I will include the same code there, and let me go for checking out with the simulator there. So let me check out with the simulator. I'm sharing the Tinkercad right now. So let us move on to that. The previous code, previous circuit, whichever we created, and let me include these two lines there. Yes, now you want to check out the previous circuit. So how do you check out? See, I have gone to this project, ATAL FDP IoT for Smart Life. Now it is in designs. You can select the circuit. When you select circuit, see, you get these two circuits which we created. One is blinking LED, the other one is buzzer. Now I want to open this blinking LED. When you click over blinking LED, it will say designed by. Okay, so I have created it and it is edited something. You again click over tinker this. It means you're going to edit it. Okay, so now I say tinker this. So it goes back and it is going to go in edit mode. Yes, fine. So now we have come here. So now let's go on to the code which we wrote already. Yes. So here in the setup, I am going to just add serial dot begin. Yes, serial dot begin 9,600. Okay. And here again, I am going to give serial dot print ln, and I say LED on. And here in the low, I say serial dot println LED off. Fine. So double quotes, within double quotes, I have given this. Now let's start the simulation. Let us see what difference. See here, now the LED is on and off. So where do I check that message? So in this text window, you can see at the bottom, there is something called as serial monitor. So you can click over, you will get here. See, it is displaying LED on, LED off, LED on, LED off. Is it clear? So a message comes here. So even if the LED has fused or something gone wrong in real time, if you want to check whether it is working, yes, you can verify. You can do that using this serial monitor. You can type a message and you can check. But this serial monitor generally in real time for what we use is for analyzing the data we do with. Let me say you where we can analyze, how we can analyze and do that. Okay. So any doubts in serial monitor? So let me stop the simulation. Okay. So fine. So let me wind up this session with this. Okay. Let me wind up this session with this. So we can continue this session, the further other implementations, still more analog inputs and stuffs. Yes. So we will do that in the next session at 2:30. So there I will give you how you can get the analog inputs, how you can write it, everything you can do it, we can see. Few interesting projects also we will see there, so which can give you a better idea. Okay, thank you. So any other doubts you have right now? If you don't have doubts, we can wind up.
Thank you, ma'am. Thank you for providing this practical session, ma'am.
Thank you.
Ma'am, the
Thank
afternoon
you.
session started at 2:30, ma'am.
Yeah, thank you, Pa. I will join at 2:30.
Okay, ma'am.
Thank you all. Have
Thank
a nice lunch, everyone. Let us meet at 2:30. Thank you.
Dear participants, kindly join the day 2 session 3 at 2:30 p.m. Thank you very much.
Link available. Link 30 minutes.
Dear participants, the day 2 session 5, the link attendance and feedback link is posted in chat box. Kindly fill it soon. It will be open up to 30 minutes only.